Now, general form is a form of an equation of a straight line that you might not be familiar with yet. It's a way of writing the equation of a straight line so that it takes this form. Some x's, some y's, some constants, and it all has to equal 0. Now, a, b and c are all just constants here, they're just numbers. So there's a few rules of thumb that you need to follow. A, or the number of x's that you have, should be positive. So there's two ways of changing it. If it's not positive, you can either add and subtract things to both sides of the equation, or you can multiply an entire equation, or divide it by that matter, by -1 to change the sign of everything in the equation. But you need to express it so that A is positive. You need to have a positive number of x's. All terms should sit on the left-hand side with a 0 on the right-hand side. And you should simplify A, B and C either by multiplying out any fractions that might be there or by dividing through by common factors. So we're trying to get those numbers A, B and C as simple as they can be without any fractions in them. So down here I've got 3 examples of equations of a line that are almost in general form, but something's not quite right about them. Let's see if we can fix them up. So see if you can spot what's not right about this one. The x's aren't first, are they? So we need to have, a should be positive, let's add that in there, and x terms come first. Let's write then y, then constants. I should have added that to my notes first. Okay, we've got it now. So we need to just rearrange these ones, put the 4x's first, then the 3y's, then the 1, and it's fixed. Now it's looking good, like general form. All right, what's the matter with this one? It's got the x's and the y's and the numbers equals 0, so it's pretty good, but it's got a fraction in there. Now, how many x's is this? If you've got x divided by 3, then really it's a third of an x, isn't it? So to get rid of that 3 on that denominator, we can just multiply all of the terms by 3, and that should fix it. So if we multiply this by 3, it just removes the divide by 3, and we just get x. If we multiply y by 3, we get 3y. If we multiply -4 by 3, we get -12. And multiplying the 0, of course, it's still 0. Check it now. It's looking good. All right, what's wrong with this one? Well, for a start, we don't have everything all on the same side, do we? So what we need to do here is get everything on the same side. Now, should I put the 3x's over there, or should I bring the others over here? Here you've got a bit of dilemma, because if I subtract 3x from both sides, I'm going to have -3x over there, and I need the term a to be positive, don't I? So it kind of makes more sense to leave the 3x's here and bring the other stuff over this side. Obviously there's a few ways you can do this. Let's do it a couple of different ways. If I leave nothing here, and I leave my 3x's here, I must have subtracted 2y from both sides and subtracted 6 from both sides. Okay, now that's looking pretty good. I've just got to put all of my terms on the left and my 0 on the right. Now have a look at what I've done there. If you treat it like a seesaw, everything on this side has got off and just swapped places with everything on the other side. They didn't change signs or anything like that. I didn't subtract or add anything to both sides. I literally just made them do a switch. So that was one way of doing that question. Another thing we could have done, if we had brought the -3x over there, let's do it up here, we would have had -3x plus 2y plus 6 equals 0. At that point, you've got two choices. You can either say, let's just multiply all the terms by -1, and that will change their sign, like that, and we've got the same answer. Or you could have said, let's add 3x to this side, subtract 2y from both sides, subtract the 6 from both sides. That would do the same thing. Okay, so you've got a few ways of getting to the same place, but as long as you're following those rules, then you've created an equation of a line in general form.